Hello everyone, here I'm going to explain what a frequency distribution table is and how to create one. A frequency distribution table or a frequency table provides some information about our variables and is a kind of univariate statistics. That means just we explain one specific variable for our participants. We are not looking for example, we are not looking for a relationship between two variables or more variables. We are just focusing on one variable. This is one example of a frequency table for a categorical variable of sex or gender. In this data set, we have two categories of male and female. And as you see, the table has one row, which is a header, and two rows, which for each category, we have one row. For example, the first row is the blue one is a category of male, and the next one is the category of female. And finally, we have two other categories for each frequency table. These are common, which include missing values and total n. In every frequency table, we include these two rows, missing values and total n. Even if we don't have any missing values, we need to report that. And just I explain a little bit about the letters. The capital or uppercase N shows total number of participants or cases that we have in our data set. And the letter F or N, but lowercase, these two letters show the frequency or the number of participants or cases for each category. For this class, I'm using an Excel file because Excel and Word are part of Microsoft Office software, which are available almost every place. And I'm not going to explain that with SPSS because many times we don't have access to SPSS and we need to prepare that, buy that, and spend some money on that. But these are almost available every place and more practical to use Excel or Word. I'm just gonna explain a little bit about the data set. Here I have an Excel file, but even in SPSS and other softwares, other statistical softwares, we have some similar format. For example, here, rows show cases or participants, and columns show variables. For example, here, just exclude the header one. I have 10 rows for participants. And I have gender, race, anxiety, exercise, and heart rate, 5 variables. That means for 10 participants, I collected data of 5 variables. Here I use the print screen of my code book. Usually when we use any data, any statistical data, we need a code book or something, I don't know what they call it, but just something like code book that describes our variables and the codes. For example, based on the code book, I see for the variable of gender, I have 2 codes. Code 1 is male and code 2 is female. Or for race, I have here 5 categories with codes 1 to 5. I'm going to explain it more in the next slide. And for example, for the variable of anxiety, here I show that how I measured it. I asked this question, how frequently am I anxious? I ask this question, I ask my participants this question with a Likert scale options, 5-point Likert scale of 1 to 5, never to always. And also I have exercise and heart rate, that these two variables are quantitative variables. And here, next slide, I'm explaining, for example, the row that I underlined, all is information for participant number 1. That means participant number 1 has a gender with code of 1. That means the first participant is a male, and his race is coded as 2. What that means? That means he's a white person. His anxiety level is 4. That means he's usually anxious based on the codes I have. I'm just looking at the code book. And he does 30 minutes exercise per day. His heart rate is 70. This is the way we read data and information in Excel file. We can use also just letters, words, like I can write, instead of 1, I can write male, and instead of 2, I can write female here. But using numbers give us some possibilities to calculate some statistical analysis, and then it's better to use numbers. Just you need to keep a code book for any data set you have. And just look at here, the numbers you see, they are so clean and there is nothing missing or nothing wrong. This is because of the purpose of the training and for the class. But in the real world, we have many errors, missings, or issues with data. Data is not like that clean and everything organized and perfect. For example, here, this is just, I made up this data. For example, look at the column of gender. You see we have a code 3. We have not defined this code already in our code book. Our code book includes 1 and 2. Then when you see a number like 3, that means it's something wrong. That means some error in data entry or anything. Just that number, we cannot use that in our analysis because that's something not makes sense. For example, look at the column of race and anxiety. We have missing data here. The ones I made a kind of orange or pink colors, that's missing data, and we just leave that blank. Or look at the last column, heart rate. Heart rate is usually between 60 and 100. When you see a number like 20 or 185, that means something wrong. That means we cannot use those data because they don't make sense. That's just, that means anytime we are going to do any statistical analysis, we need to clean the data, we need to screen the data and make sure that our data is correct and reliable. Now I'm going to explain how to make a frequency table in a Word file for a categorical variable of gender based on the data I provided. And now I need to switch to a different file. So I just open the Word file, and I'm going to go to Insert, Table. And before creating a table, I need to explain something. When, for example, we are creating a frequency table for gender, just remember we need one row as a header, one row for female, one row for male, another row for missing values, and finally one row for total number. That means I need 5 rows, and I need at least 2 columns. Why? The first column is showing categories and the second column showing numbers. Then I'm going to create a 2 in 5, the size of the table. here I'm going to add here like categories. And here N or F, just you need to use only one of them. Here, male. Okay, and we need to go back and forth many times between the Word file and the Excel file. I'm going back to the Excel file. So because we have a small data set here, we can just go ahead and count ones and twos, which is so easy. But in the real world, we may need to work with big sample sizes, like 1,000 participants or something like this. And then the best way, there are some formulas in Excel, we can count numbers, but the easiest one that we can use is that I recommend you to sort the data based on gender. How? I'm going to choose all the numbers. Why I'm choosing all the numbers? Because if I don't choose all the numbers, Excel may mess up the data. For example, it may just sort for one specific column, and then my data gonna get messed up. I'm choosing all the data, going to data at the top, you see here at the top, and sort by. Here I can choose any column. I'm gonna choose gender and gonna order these based smallest to largest, and then okay. As you see now, I sorted data based on gender. That means all the ones are come first, and then twos are coming. Now I'm just highlighting for clarity. This makes this makes it a little bit easier to count them. For example, we see here now we have 6 people who are males and 4 people who are females. Now I'm going back to the Word file. Here I'm just adding 6 for male and 4 for female, and there was no missing value in my data set. And then total N is 10. This is the way we create a frequency table. Sometimes it's not enough to report only number or frequency. Sometimes we need to know the proportion or percentage. For example, it's more useful to know what percentage of our participants are males or what percentage of our participants are females. For this purpose, we can calculate proportion, which we can divide frequency by total N, which gives us proportion. And if we multiply proportion by 100, we can get percent or percentage, which are more helpful and giving us some extra information about our participants and variables. Now, I'm going back to the table we just created and add one column to show the percentage. Before I go back to modify the table and add this column, I just need to explain here that for our gender variable, I already calculated percentage. For example, for male, as you remember, we have 6 participants out of 10. Multiplying 100 becomes 60%. And for female, is 4 female participants divided by 10 total number, and then multiplying 100 becomes 40%. Now I'm coming back to Word file. Okay, here as you see, my columns are kind of wide. Let me first make them narrower. How to add one extra column? I'm just gonna right click on the table, and you see here insert. I'm gonna choose insert columns to the right, and I'm gonna label it as %. And then, as you remember just now, we calculated that male percentage is here is 60%. And female percentage is 40%. Missing value 0. And finally, total N should be 100%. And how to interpret these numbers? That means 60% of our participants are males and 40% are females. As you see in the screen, we can also create frequency tables for a quantitative or ordinal variables. As you see, for example, for anxiety, I created a frequency table, and you see, for example, 10% of participants are never anxious, or 20% are always anxious based on the numbers you see now. Something interesting to know is that for quantitative variables, we can add an additional column to show cumulative percentage. But for categorical variables, this is almost useless. But for quantitative variables here, I added for anxiety, I added the last column, which as you see, for example, if you look at the second row, 30%, what that means, cumulative percentage, that means 30% of our participants have the anxiety of level 2 or less. Again, if you add these 30% to 20% of the next row, you can get 50% for cumulative number, and that means 50% of our participants have the anxiety level of 3 or less, and so on. You can go with 80% and 100%, you can interpret in this way. One thing you need to know about quantitative variables, frequency tables for quantitative variables, is that sometimes we have a lot of scores. For example, for heart rate, we have between 60 to 100. And if you want to make a frequency table, it's gonna have 40 rows. One row for heart rate of 60, one row for heart rate of 61, one row for 62, and that's gonna be very long and a huge table, and sometimes really not so helpful. And what is the solution for that? We may use grouped frequency distribution tables. What that means, that the heart rate of 60 to 100, I'm gonna divide it like to 4 groups: 60 to 69, 70 to 79, 80 to 89, and 90 to 100. And then I'm gonna create a frequency table based on these 4 categories. In this way, I'm gonna save space and many of the rows are not necessary to include in a table. And this can give me a better picture of heart rate among my participants. Here I created the table, and we can just complete the numbers. And again, to complete the numbers, I'm going back to the Excel file. and I'm sorting the data based on heart rate. I choose all the numbers, data, sort. And here I'm choosing heart rate. Okay. See, here you see the heart rate is ordered from smallest to largest. Based on the category I defined, these three numbers belong to category 1. These ones belong to category 2. Category 3. And finally, this one. I just need to go back and forth to enter this data, but just for the sake of this video, I'm gonna just memorize them and go to Excel file one time. Here was 3, 4, 1, 2. Okay, I'm going back there. Here, I'm going to add the numbers here. 3 cases for the first category, 4, 1, and 2, and 0, and 10. And the percentage, I can just calculate them easily because the total number is 10. And here now I have the frequency table, a grouped frequency table for the variable of heart rate.